Have you ever wondered how mixing gases works? It's more complex than it seems. Today we dive into Gibbs paradox and explore the entropy of mixing. This concept is crucial in thermodynamics and helps us understand why systems behave the way they do. First, let's define Gibbs paradox. It states that mixing two identical gases unexpectedly increases entropy. We typically equate mixing with the higher disorder. But why does this paradox arise? The answer lies in the nature of particles and their indistinguishability. To understand the entropy of mixing, we start with two separate containers. Picture one filled with gas A and the other gas B. When we open the barrier, gas A and gas B mix freely. However, according to classical thermodynamics, the change in entropy should reflect this process. We can calculate entropy following the equation stated below. Here, N is the number of molecules, R is the gas constant, and X represents the mole fraction. Now, this formula works great if A and B are distinct. However, if A and B are identical, the scenario shifts. The naive application of the equation suggests a discrepancy. It implies that creating disorder from the same identifier raises entropy. This is something that doesn't align with physical reality. This paradox shows the importance of recognizing the particles' indistinguishability. By accounting for this, we find that the mixing process doesn't lead to a discernible increase in entropy. This understanding resolves the Gibbs paradox. For example, imagine you have two jars of marble. One jar has red marbles and the other has blue marbles. If we mix them, we see a clear change: more colors, more disorder. But if both jars had the same color marbles, the act of mixing brings no new disorder. It brings no change. They remain the same at a foundational level. In summary, the Gibbs paradox challenges our perceptions of mixing. Mixing particles that are indistinguishable leads to an unexpected outcome in entropy calculations. By grasping this concept, we ensure a clearer understanding of thermodynamic particles. Want to learn more about thermodynamics? Subscribe for more engaging content as we dive deeper into the world of science.